Hi kids! Last class we studied image formations of lenses. We also did some numericals based on the lenses part, right? This class we are going to do where we are going to understand what do we mean by power of a lens, right? Normally, if you have got specs or maybe in some point of life, you might get specs. There must be some people in your family members, one of them at least must have had specs, right? So whenever you go to your ophthalmologist, he or she gives you, I mean, when you do an eye checkup, they put in lenses of different powers and make you see through it, so that they want to analyze if there's a defect, and if there's a defect, what should be an appropriate lens for you to see a object clearly, right? So we need to understand over here, what do we mean the power of a lens, the number, the card which they give us, what do we mean that by that, right? So let's see now. Okay, so power of a lens, what is basically power of a lens? It's the ability, right? The definition is very important because normally come for 1 mark questions. So power of a lens is basically the ability of a lens to either converge or diverge. We know there are two types of lenses. One is a convex lens and another is a concave lens. A convex lens converges at a point. A concave lens, right, diverge from a point. So we say this is a diverging lens, this is a converging lens. So how much convergence, okay, the ability to converge, how much convergence will depend on the power of a lens, right? If the power is more, convergence will be more. If the power is less, convergence will be less. Let's see. It's the ability of a lens to converge or diverge the light rays depending on its focal length, right? So, for example, if I say, I'll show you over here, right? I have got two convex lenses now. Okay, one lens is a very thin lens like this, right? And another lens, I have a little bulging lens. Okay, this also has principal axis. This is also principal axis. So we know both lenses, both either it's convex or concave, both of them are made up of spherical surfaces, right? So if this particular lens is made up of a spherical surface, so that means if I just extend these spherical surfaces, my center of curvature is going to come somewhere over here, right? Because as the lens is very thin, so this is going to be the center, that is, this is going to be your 2f1. So in between this is going to be my f1, 2f1, right? So this is the focal length. Now when the lens is a more bulging one, this is a more curved surface like this. So according to this, my center of curvature will lie somewhere over here. So this is 2f1 and this will be my focus, f1. So focal length will be this much smaller. Okay. So if we compare the two lenses, as far as a thin lens and a thick lens is concerned, a thin lens will have more focal length. A thick lens, on the contrary, will have less focal length, right? So it depends on the amount of focal length, how much are they going to converge, because we know whenever rays from infinity, how do the rays from infinity come? The rays from infinity come in this format, parallel, and they get converged at a point. Now, when these light rays come in this type of lens, they will get converged like this, very close to the lens, right? So Degree of convergence. Can you tell me in which lens is the degree of convergence more? Obviously, the lens with less focal length, degree of convergence is more. In this one, this is the second. In the first scenario, when the focal length is more, degree of convergence was less because it got converged over here at this much distance. Here it got converged over here itself, right? So more the focal length, less is the convergence. Less the focal length, more is the convergence, right? So how much will it get converged or how much will it get diverged will be given by power of a lens, right? So as the formula for power of a lens goes, power of a lens is inversely proportional to focal length. Okay, or we can directly come with the formula power is equal to 1 upon f, where f is always in meters. Okay, focal length in calculation of power, focal length always will be in meters. Even if in the question say they tell you that the focal length is 10 centimeter, while calculating the power, please put the focal length as 0.1 centimeter. Okay, sorry, 0.1 meter. It should always be in meters, right? Focal length is always kept in meters while calculation of power. Okay, so this tells us as less the focal length, more is the power. More the focal length, less is the power. So it has an inverse relationship with power, right? More the power, more is the convergence or divergence. Less is the power, less is the convergence or divergence. Understood the relationship? Good. Let's go to the theory part now. Okay. So it's the ability of the lens to converge or diverge. Convex lens, for example, of very short focal length, bends the light rays through large angles by focusing them close to the optical center. This is this case. Okay, it's focusing them very close to the optical center. Okay, now in the second one, as far as the same thing will happen. This is a concave, thick concave lens. Again, rays parallel from infinity will come over here. Axis. They will get diverged. Okay, and as they get diverged, we will just take these rays behind. So these rays behind, they meet over here. So this is the point, very close, they get diverged, right? More the divergence, so its focal length will be here, right? Okay. So degree of convergence or divergence of light achieved by the lens is expressed in terms of power. How much will it get converged or how much will it get diverged is told to us by the power of the lens, right? So if we want to define, this can come for 1 mark, but if define what do you mean by power of a lens. So power of a lens is defined as reciprocal of its focal length, right? Reciprocal of the focal length. Okay, it is represented, power is always represented by P, and the SI unit of power is always kept as diopters. DIOPTRE. Do not make a mistake with the spelling. It's always diopters. D. Okay. Focal length should be measured always, as I've told you, focal length should always be measured in meters. So this is your formula for power. Power is always equal to 1 upon F, where F is in meters and power is in diopters. Understood? Okay. Now, what do you mean by 1 diopter of a power? 1D. 1D always means that power of lens whose focal length is 1 meter. When we'll get power as 1 meter? So when power focal length is 1 meter, we know 1 upon 1 is going to be 1. So this is going to be 1D. Right? So now, what will be the power of convex focal length? What is the sign of focal length in case of a convex lens? Convex lens, we know lights get converged on the next side of the lens. So that is the focal length. As focal length of a convex lens is positive, as focal length is positive, power will also be positive. Because what is power? 1 upon f, 1 upon plus f, power is going to be positive. Concave lens, what is the focal length? Focal length is negative. It falls on the same side, right? So as focal length is negative, power will also be negative. That means P is equal to 1 upon f, 1 upon negative f, so P is also negative, right? So it will be negative D. Okay. So now, if for example, if an optician prescribes you glass lenses and they have given you a power of plus 2D. So what do you mean by that? So you need, so when they say that you have got a glasses or the number of your eye lenses or the power of your eye lenses is like plus 2D, that means you need to use glasses. We know what is P. P is equal to 1 upon F, 1 upon F in meters. Now what is my power? So power is plus 2D. P is equal to plus 2D, which is equal to 1 upon F. So therefore, what will be focal length? Therefore, focal length will be 1 upon 2, which is equal to 0.5 meters, plus 0.5 meters. Now, this tells us that we need to use a lens who has a focal length of say 0.5 meters, so that's 50 centimeters, and positive sign indicates as the focal length is positive, that means we are using a convex lens. Understood? So plus 2D, plus sign will always tell us that it's a positive focal length. So type of lens which we are using will be a convex lens, right? Power minus 2D. Again, we know what is power. Power is 1 upon focal length in meters. So therefore, this is equal to minus 2.5 diopters equal to 1 upon f in meters, right? So therefore, 1 upon, therefore, we just exchange this. F will be equal to 1 upon minus 2.5, right? So this can be equal to minus, I'll multiply by 10, 10 upon 25, which is equal to minus 2 upon 5, right? 10, 5 twos are 10, 10.5s are. So minus 2.5, so that's minus 0.4 meters. Minus 0.4 meters tells me that minus 2.5 diopters tells me that I have to use glasses, which glass lenses, which has a focal length of say 40 centimeters, and negative sign indicates that I should be using a concave type of lens, right? This is the way we need to interpret the information given to us, right? Understood? Okay. Now, when 2 or 3 lenses come together, okay, if 2 lenses with focal length f1 and f2 are kept in contact with each other, the combination has an effective focal length, which is given by 1 upon f is equal to 1 upon f1 plus 1 upon f2. Same way, when we have 2 or 3 lenses which are kept in contact with each other like this, okay, or the scenario can be like this, okay, somehow they are kept in contact with each other over here, right? It can be a thick lens, okay. In this case the total, so let's say this is p1, p2, p3 of the three powers. So total power or the effective power of this combination will always be equal to p, which will be a normal addition of all the powers. So it is p1 plus p2 plus p3. It will be addition of all the powers. So that's your combination of lenses. Combination of lenses will be a simple addition of the powers, okay. Same way, combination focal length 1 upon f can be equal to 1 upon f1 plus 1 upon f2. In this case, it can be plus 1 upon f3 as well, okay. This way you need to find out, right? Next, okay, let us do some numericals based on your lenses. Quite easy, might come for 1 or 2 marks. It's okay. The question says a convex lens forms a real and inverted image of a needle at a distance of 50 centimeters from it. Image is given. Where is the needle placed in front of a convex lens if the image is equal to size of the object? We know, okay, this is a very important thing which is given. It tells us that the image is equal to the size of the object. That means there is only one case when image size, right, or size of the image is equal to size of the object. What is that situation? Okay, when the object is placed at 2f1 and the image is placed at 2f2. So that means the image we get is at 2f2. So when object is at 2f1, so it's a convex lens. I'll show you with the help of ray diagram as well. Okay, for optical center f1, 2f1, f2, 2f2. Let this be my object AB. I'll show you with the help of ray diagrams as well. So one ray parallel to principal axis passing through focus, another ray passing through optical center. Okay, passing through optical center. Yes. So now I just need to take this thing. So this is where my image is formed. A dash, B dash. Both are of same size. Now this 2f1 is basically the center of curvature C1, and this distance between optical center and center of curvature, what is it? It's radius of curvature, right? Radius of curvature. So what is this distance given? This distance is given as 50 centimeters. So that means if R is equal to 50 centimeters, which type of lens it is? It's a convex lens. So, okay, let's find out next. Our radius is 50 centimeters. So therefore, what will be focal length? Focal length, we know it is always R by 2. So therefore, F is equal to 50 divided by 2, which is equal to 25. As the lens is a convex lens, F is going to be positive 25, right? Perfect. Now, from this focal length, we need to find the, what do we find? We need to find out the power. Okay, and one question they're asking, where is the needle placed in front of the lens? The needle is placed at a distance of 50 centimeters in front of the lens, and the same distance it is placed at 2f1 because we are getting the same image. Okay, when we get the same size image, both object and image are kept at the center of curvatures of the respective spherical surfaces, right? So now power, we know what's the formula for power. Power is always equal to 1 upon f in meters. So now your focal length is 25 centimeter. So power will be equal to 0.25 meters. Okay. So this will be equal to multiply by 100 upon 25. P will be equal to plus 4D. Right. It will be plus 4D. So hence the power of this type of lens is equal to positive D plus 4 diopters, right? Next we have find the power of a concave lens of focal length 2 meters. Again, concave is given, so if it's a concave lens, how will be the focal length? Focal length is going to be negative, so it's minus 2 meters. We know what is power. Power is equal to 1 upon F in meters. Write the formula, just box it. So therefore power is equal to 1 upon minus 2. So this is equal to 0.5 diopters. So hence the power of the concave lens is negative 0.5 diopters. This is the way your answer is going to be there, right? Quite easy. Next, now 3 lenses having powers 2, 2.5 and 1.70 are kept touching in a row. What is the total power of a combination? Now, if signs are not given, that is 2, 2.5, 1.7, so that means all 3 are positive, right? So let P1 be equal to plus 2, P2 be equal to 2.5 and P3 be equal to plus 1.7. Okay, diopters. We know power of combination P is always equal to P1 plus P2 plus P3. So therefore, your P will be equal to 2 plus 2.5 plus 1.7, which is equal to 4.5, 5.5, 6.2. So power is going to be plus 6.2 diopters. This will be the total power of the combination of lens. Okay, quite easy. Next, we have find out the focal length of power of minus 2.5 diopters. Okay. Focal power is given as minus 2 diopters. What type of lens is this? Okay, we know power is equal to 1 upon f. So therefore, f will be equal to 1 upon p, which is equal to 1 upon minus 2. So therefore, f will be equal to minus 0.5 meters. So as focal length is negative, we can also write this as this will be equal to minus 50 centimeters, right? As focal length is negative, what does negative tell us? Negative tell us that this is a concave lens or diverging type of lens, right? That's it. Quite easy questions. Hardly one mark questions might come. Okay. One says a doctor has prescribed a corrective lens of plus 1.5D. So power is given as positive 1.5 diopters. Find the focal length of the lens. Is the prescribed lens diverging or converging? So we know P is equal to 1 upon F. So therefore, F will be 1 upon P, which is equal to 1 upon plus 1.5. This is equal to, if I multiply by 10, 10 upon 15, which is equal to 10 upon 15 is 2 by 3, right? So therefore, focal length is going to be 2 divided by 3, that is in meters, right? So if I have to convert this into centimeters. So therefore, F will be equal to 0.67 meters. Focal length will be plus 67 centimeter, right? So as the focal length is positive, what does positive sign tells us? Positive tells us that it is which type of lens? It's a convex lens. And what is a convex lens? A convex lens is a converging lens, right? Okay, that's it. Such easy type of questions might come from the lenses part. You need to, just keep in mind that power is always the reciprocal of focal length, and it depends what is the sign of focal length. The same sign will be for your power, right? Okay. Next class is a very interesting class. You guys are gonna love the class. We will study the structure of human eye, how we as human beings perceive things, how are we able to see, what are the different parts of the human eye, how does it work, what are the different refractive defects. As in, you must have seen there are so many people who get specs, who get spectacles, glasses. Why do they get? What is basically happening inside their eyes? What is the defect? Some people can see nearby, some people cannot see nearby. Some people cannot see far off things. So what is it making them not see, or making their visibility into a restricted one? Okay, so we'll study about all these things. Very interesting. Stay tuned for it, right? And do go through all the videos till now. Practice, go through the textbook. Okay, if any doubts are there, please post in the comments. I will personally look into it. Thank you. Bye bye.